Hi, one of the types of problems you're going to be asked to do during your semester exam tasks is to write your own problem. Okay, so what you're going to be given as you go through is you're going to be given your topics that were covered. So in Unit 1A, we talked about algebraic proofs, naming geometric figures, segment addition postulate, distance formula, midpoints, and fractional distance. So our write our own problem question is going to have to cover one of these topics for problem 1, for Unit 1A. Okay, when you look at this page, you're going to be given a picture that you can use for Unit 1A or whichever unit you're working on. When I look at this, one of the things I'm tempted to do, because I want to try to do something pretty simple for myself, is just to go, oh, well, maybe I could just ask them for slope, the rise over the run, because that's pretty simple to do, right? Rise over run. But when I look back here, slope, unfortunately, is not in this unit, so I'm not going to be able to ask them for slope. But I can ask them to find the midpoint of the segment ST. So that's what I'm going to go ahead and do. I'm going to say, what is the midpoint of, and we don't have a whole, sometimes it can be difficult to get our math symbols in the Google Slides, but you can always just type segment ST if you want to be quick about it, rather than finding the little bar that would go over it. Okay? So segment ST is going to look like this, and they don't have to be able to draw it to be able to find it. And hopefully we remember that to find the midpoint, we need to take the average of the x and y's. But what could maybe somebody do wrong, right? That's kind of what I want to know is, what could we do wrong to figure out a midpoint? Okay, well, they might say, well, what if I look at my rise and my run and I divide them in half, right? Because instead of rising 3, I'm only going to rise 1.5. Okay, instead of running 7, I'm going to run 3.5. So I'm going to come over here to my answer choices box, and next to A, I'm going to say maybe they just took that rise of 3 and divided it in half. And then they took that run of 7 and divided it in half, because they knew they were finding the middle, right? So they did that. Now, we know that's wrong because when we look at it, 1.5 and 3.5, sorry, 1.5 is here, and then 1 to 3.5. It actually does look pretty close to the line, okay? But you're going to find it's not going to be your actual answer, okay? So let's write down what the mistake was, because it does tell me right here that I need to say what error was made for my wrong answers. So I'm going to put that down here, okay? My mistake here was we just divided rise and run in half, okay? All right, so now let's say, what else could we do? Well, what if they said, oh, I need to add these, I remember I need to take the average of my x's and the average of my y's, and to do that I add them together and then I divide it in half, right? So if I add them together, negative 3 plus a 4, negative 3 plus 4 is going to be 1, right? Because negative 3 plus 4 is really 4 minus 3. And then when I look at my y values, I'm going to have a 2 and a 5. So 2 plus 5 is 7. And what was my mistake? My mistake was I added my x and y values together. I forgot to divide. We didn't divide them in half. Okay. Let's see, what else is something we could do? What if instead of adding our x's and our y's together, we subtracted them and we did 4 minus a negative 3 and 5 minus 2, right? 4 minus a negative 3 is really 4 plus 3. And 5 minus 2 is 3. So here my mistake was we subtracted x and y values. And then let's see, one more thing we could maybe do. Oh, we need the right answer. We haven't found the right answer, right? So we know when we add them together, because we added them here, we forgot to divide in half. We got our 1 and our 7, so I need to divide them in half. So my 1 divided in half is going to be 0.5. And my 7 divided in half is going to be 3.5. So 0.5 and 3.5, if we look on the graph, oops, I lost our page. If we look on the graph, 0.5 is halfway between 0 and 1, and then 3.5, 1, 2, 3, 0.5. That's our midpoint right there that divides this into 2 equal pieces. And so I'm going to come over here and mark that it's my correct answer. Now, is that the only question I could have possibly asked for this problem, right? I could have also, if I look back here, I can see that I could have also done a distance formula problem. I could have also done a fractional distance problem. Since there's points there, I could even talk about how we name a point, right? Why does S have to be a capital letter, right? There's other things that I could do here, okay? If I look, I have some other examples here that I've used, okay? So I have, this is the one that we just did as one of my examples. Another example is 7 is, what is the length of segment ST? So I use the distance formula to get my length. And remember, the distance formula involves a square root, so maybe we didn't apply the square root to get a mistake. Or maybe instead of using my distance formula, we just said, oh, it's a vertical change of 3. Or sometimes we just count this way and go, oh, 7, right? We could also go, some people go 7, 8, 9, 10. So 10 is the distance, right? So that's another mistake that somebody could have made. They added the 7 plus the 3 instead of using it in the distance formula. Okay. Another question we could have asked is we could have used fractional distance. What's 1/4 the distance from S to T, right? And so our correct answer is 1.904. And then maybe we took that whole distance that we found on the last problem that was correct, 7.616. But since we're looking for 1/4 that distance, we forgot to divide that by 4 to get the correct answer. Okay. Maybe we didn't apply the square root, but we still divided by 4. Here we didn't apply the square root or divide by 4. We just still had that 58. Okay, so those are examples using this picture. For Unit 1A, you'll have a problem like this. It'll be a different picture, so a different type of question you'll have to come up with, but it will fall under these topics. Okay, Unit 1B, we discussed angle relationships. And the example problem I have here is I have this picture that has all sorts of stuff going on. It's got X's, it's got Y's, it's got angles that are letters, points that I could use to name angles with. So there's lots of things that I could ask about this picture. Okay, I could ask about the relationship between 5x plus 4 and 3x minus 24 and say, what is the relationship? And the only thing I know about them is that they're adjacent to each other because it almost looks like they make a line, but they don't quite, right? So I could say, what's the relationship? They're adjacent would be my correct answer. Linear pair would be wrong because they don't quite make a straight line, right? We could choose vertical as one of our options. They're not vertical, definitely, right? They're not across from each other. They're next to each other. Then I need to come up with still something else, like maybe supplementary or complementary, and why that's wrong. The examples of things that I had for my examples is I said, well, what is the value of x? Because that seemed like the most logical question, right? I know these two are vertical, so they're going to equal each other. So when I saw 5x plus 4 equals 114, I get 22 as my answer. But if we forget and we just take away the 4 and we still 5x equals 110, we forget to divide by 5. Maybe we set these two equal to each other instead of my vertical angles equal to each other. Or maybe we added the 4 to both sides instead of subtracting the 4. Just a silly math mistake when we solved it. Okay. So what is the value of x is something I could ask for this picture. Same picture, but what is the value of y? And again, mistakes and why I got them, why they're mistakes, how we got the mistake answer, and the correct answer. And then here, this is a nice one. Find the measure of angle ABC, right? So in this one, the person who has to solve this one, poor thing, they have to find x, plug it back in, use that to find, really just find this angle, and then it would be vertical to this one, right? So lots of different things we could ask with this picture. Again, you're only going to have to come up with one question and then your 4 answers. One's correct, and then 4, how did you get 3? How did you get those wrong 3 answers? That's Unit 1B. Unit 2 was our logic and lines with our reasoning, our counterexamples, conditional statements. Here's where I've got my slope my equations, distance to a line, transversals, and parallel lines. So let's see what picture we have here. All right, we've got a transversal and parallel lines. Okay, so we could ask to find x, we could ask to find y, we could ask about the relationship between y and 114, we could ask about the relationship between the x plus 12 and the y. Lots of questions we could put down here for our prompt and then choose our answer choices. Let's see what examples we have. The first one, find the value of the angle adjacent to y. So here's y, adjacent to that would be either this angle or this one up here, right? So you have to know that these two are corresponding. So y is 114, and then these two are supplementary, so you just take it away to get your correct answer. And then how do we get these wrong answers? Another thing you could ask is to actually find the value of y, which is pretty simple in this one since they're corresponding, they're both equal. So it's just 114, and then how are you getting these wrong answers? Another question with this same picture is to find the value of x, right? So you have to know that if this is 114, this is 114, and then these two add up to 180. So my 114 plus my x plus 12 make 180 because they're supplementary. And then so you find your correct answer and then your wrong answers and how you got the wrong answers, what mistake was made. Unit 3 is called Congruent Triangles, but it actually has lots of stuff in it. It has classifying triangles, triangle sum theorem, exterior angle theorems. It does have congruence in it, and then it also includes isosceles. So when we look at the picture, it's actually not a congruent triangle problem that I have here. It's an isosceles triangle problem. And so we know the tick mark means these two are equal. So I could say which two sides are equal would be a nice easy question I could ask, right? It might be harder on that one to come up with the wrong answers than to come up with the right answer. I could ask to find x, and then to get wrong answers, you could set wrong things equal to each other. I could ask to find how long is AC. I could ask to find how long is AB. I could ask to find how long is BC. I could ask to find the perimeter of the whole triangle, right? Lots of things I can ask. Let's look at the three things that I did ask. The first one, find the value of x. So straightforward, set these two equal to each other, solve for x, right? You end up getting a 1.5. Things you could do wrong that I see all the time is kids add these three together and set them equal to 180 because they instead of the angles equaling 180, we're getting those confused with our sides. Maybe they set the wrong two equal to each other. Maybe they found x 1.5 and then they plugged it in and found the actual length here was 7. Okay, so they did find x, they just stayed on that train too long, right? They didn't get off when they were supposed to get off. Another thing is find AC. So I have the same answers I had before. All I did was say, well, now they found x here, but it's a mistake now because they didn't plug it in. The correct answer is now 7. They had to plug it in. Okay, and then find AB. So this time they had to set these two equal and solve for x and then plug it into this one. And so right answer right here, and then how you got your wrong answers. And finally, the last unit we just finished, Unit 4, Relationships and Triangles, that has all your centers and area, triangle sum inequality, hinge theorem, exterior angles, and inequalities. The picture I have is a hinge theorem problem, okay, where I have, it looks like side angle side, but my angles are not congruent, so they're not congruent triangles. And so I know that tells me something about the relationship between these two sides across. So I can ask questions about the hinge theorem. I can ask questions about which segment will be longer. How do you know? There's lots of different questions that can be asked. Let's see what questions I did ask. On the first one, so this is a good example of they don't have to be problems where you're doing actual calculations. They can be vocabulary based. What is the name of the theorem that would allow you to find the restrictions on y? Well, the correct answer is hinge theorem, and then you have to come up with the wrong answers also. So exterior angle inequality, triangle sum inequality, and side angle side congruence is what I came up with. Okay, here, which inequality is correct? So here, they're not having to solve the inequality, they're just having to set them up, right? So 2y plus 10 is less than 4y minus 8, because, right, the 2y minus 10, or plus 10 is across from the smaller angle, so it has to be less than. So this is my correct answer. ST is less than SR. Well, no, we just said this one is less than, right? So this one can't be less than. SR is greater than ST. SR, we just said again, this one's my smaller one, so SRS can't be greater. Oops, I moved to that. SR is greater than ST. Oh, that's one I just looked at. And then 4y is less than 2y. So my 4y is less than, no, my 4y comes from the bigger angle. So my 4y is greater than, right? So that one didn't work. All right, and then the last question I came up with is actually solving that, right? What are the restrictions on y? And so when you solve it, you get that y has to be greater than 9. One of my choices was, oh, we'll just use the same thing but put the wrong inequality symbol. And then I was like, I don't know what I could use for the other two. What might somebody accidentally do? Oh, well, maybe they'll compare y to the angles instead of to each other, right? So y has to be greater than 35 or less than 31, okay? So hopefully going through this helps to figure out exactly what we're looking for. Again, you don't have to come up with 3 examples like I did for each one. I just wanted you to see how everybody isn't necessarily going to come up with the same problems, okay? So everybody's answers should be unique because there's lots of different types of questions and lots of different ways you can get wrong answers, okay? Thank you so much for watching. I hope this helps. If it doesn't, please, please, please make sure you go to Sync Time and ask your teacher for help. Thank you so much for watching.